Class 12 Mathematics, NCERT New Delhi and COHSEM Manipur. Unit 1 Relations and Functions. Topic Inverse Trigonometric Functions. Subtopic Elementary Properties of Inverse Trigonometric Functions. Exercise 2.2. Prove that Roman number 1 sine inverse of 1 by x is equal to cosec inverse x, where x is greater than or equal to 1 or x is less than or equal to minus 1. Cos inverse of 1 by x is equal to sec inverse of x, where x is greater than or equal to 1 or x is less than or equal to minus 1. Tan inverse of 1 by x is cot inverse of x, where x is greater than or equal to 0. Statement ahum si prove tausi property ni. Ahanba si prove tausi let cosec inverse of x equal to 1. Right la riba cosec inverse x si y ga mana halasi. Then cosec asina y da satlabadi x equal to cosec y lere. 1 by x reciprocate x की reciprocate ni 1 by x ni cosec की reciprocate 1 by cosec to the sin ni sin y का माना रे sin सिना अमोक 1 by x की नकन ला अबदी sin inverse of 1 by x from the y ले होरे y की original value दी y दी कया का माना होई cosec inverse x का माना रे hence Roman number 1 is proved. Similarly you can do others. Property 2. Prove that sine inverse of sine x is x, where x is belongs to closed interval minus pi by 2 pi by 2. Cos inverse of or sine of sine inverse x is x, where x belongs to closed interval minus 1 1. Roman number 2. Cos inverse of cos x is x, where x belongs to closed interval 0 pi, and cos of cos inverse x is x, where x belongs to closed interval minus 1 1. Roman number 3. Tan inverse of tan x is x, where x belongs to open interval minus pi by 2 pi by 2, and tan of tan inverse x is x, where x belongs to r. Roman number 4. Cot inverse of cot x is x, where x belongs to open interval 0 pi, and cot of cot inverse x is x, where x belongs to r. Roman number 5. Sec inverse of sec x is x, where x belongs to closed interval 0 pi minus pi by 2, and sec of sec inverse x is x, where x belongs to r minus open interval minus 1 1. Roman number 6. Cosec inverse of cosec x is x, x belongs to closed interval minus pi by 2 minus 0, and cosec of cosec inverse x is x, where x belongs to r minus of open interval minus 1 1. High statement singsi prove tausi. Ahanbada Roman number 1. Sin x asi bracket ki manung dala sin x asi y ga mana halasi, that gives x equal to sin y ga nakanda sakrabadi sin inverse y. Sin inverse y sina right lebe sina left ire, left lebe x na right ire. Sin y की original value दी y दी sin x का मान हुई y जो sin x ना सिंजलो x पंगे sin inverse of sin x दी x तारे. Similarly you can do others अते लेमोरी बसिंग शिलोइना prove तो बंगमने. 3. Property 3. Prove that sin inverse of minus x is minus sin inverse x, where x belongs to closed interval minus 1 1. Tan inverse of minus x is minus tan inverse of x, where x belongs to r. Roman number 3. Cosec inverse of minus x is minus cosec inverse x, where modulus of x is greater than or equal to 1. Haribasing si prove toksi. Ahan bada Roman number 1. Let sin inverse of minus x is y gaman halasi implies sin inverse na y ginakanda sakrabadi minus x equal to sin y. Minus the both side to put it we get this. Amokso sige minus asi manung the sanghang krasi sin of minus y. Sin asum the la abadi sin inverse x asum the minus y le hore. Minus y, y की original value this sin inverse sige minus the both side the puriro aduga interchange toro minus y do minus 1 na puriro badi y so minus the puriro we get this y ki original value this sine inverse of minus x ni y this sine inverse of minus x na sindokro asumna sine inverse of minus x ni minus sine inverse x haibasi phange. Similarly you can do others them how ribasing chu chap mana ba mawong da pangthok phangamani prove to bangamani. 4. Prove that cos inverse of minus x is pi minus cos inverse x where x belongs to closed interval minus 1 1. Roman number 2. Sec inverse of minus x is pi minus sec inverse of x where modulus of x is greater than or equal to 1. Roman number 3. Cot inverse of minus x is pi minus cot inverse x where x belongs to R. Roman number 1. Let cos inverse of minus x is y implies minus x equal to cos y minus the both side of purity we get x equal to minus cos y minus cos y as cos of pi minus y haina ibi cos na muk x kana kana thanga badi cos inverse x right pi minus y y ki original value di cos y asumda thanga asi pi thamamaga cos inverse na summa sakha si phange y gidi originally cos inverse of minus x na sindokro pi minus cos inverse x, hence Roman number 1 is proved. Assume similarly you can do others to Roman number 2 amasung 3 so siga chap mana mamong na pangthok pangamani. Number 5. Prove that Roman number 1 sine inverse x plus cos inverse x is pi by 2 where x belongs to closed interval minus 1 1. Roman number 2. Tan inverse x plus cot inverse x is pi by 2 x belongs to R. Roman number 3. Cosec inverse x plus sec inverse x equal to pi by 2. Modulus of x greater than or equal to 1. Had statement sing prove toxi ahan bada Roman number 1. Let sine inverse of x to y gamana halasi then x equal to sine y. X sine y have a co function palo cos of pi by 2 minus y gamane sine y cd cos of pi by 2 minus y co function palo badi cos of 90 minus y di sine y basumna ire cos na x na kandala abadi cos inverse x equal to pi by 2 minus y sumna transfer to a left asumna y go distant value dudi kaya gaman haure sine inverse x asina sumna iro sina somda iro pi by 2 lere, hence Roman number 1 is proved. Roman number 1 is proved. Similarly, you can do others atay sing su chap mana ba mo no pangtok pa yani sige ko function steps si katang khangagalore. Number 6. Prove that tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy where xy is less than 1. Roman number 2. Tan inverse of x minus tan inverse y is equal to tan inverse of x minus y by 1 plus xy where xy greater than minus 1. Roman number 1. Let tan inverse x to na e gaman halasi tan inverse y to na b gaman halasi then by inverse na the x equal to tan a and y equal to tan b. We have tan of a plus b is equal to tan a plus tan b by 1 minus tan a tan b. Tan na sumasakra from the left a plus b equal to tan inverse of something. A की value di tan inverse x का मान हाउरे b की value di tan inverse y का मान हाउरे tan a अदु di right to थमो tan a di x ने tan b di y ना मान रबदी x plus y by 1 minus xy assume Roman number 1 si prove tawre. Roman number 2 tan inverse x so sab mana ba mong rasum na pang tho a aduga tan we have tan of a minus b di tan a minus tan b by 1 plus tan a tan b siga manare tan asum sakra badi a minus b equal to tan inverse of something a amasu b ki value piselasi a tan a amasu tan b ki value pisela we get this. Roman number 1 amasu 2 chap mana mong prove tawre. Number I. Prove that Roman number 1. 2 tan inverse x equal to sine inverse of twice x by 1 plus x square modulus of x is less than or equal to 1. Roman number 2. 2 tan inverse x equal to cos inverse of 1 minus x square by 1 plus x square where x is greater than or equal to 0. to tan inverse x equal to tan inverse of twice x by 1 minus x square, where x is lying between minus 1 and 1. Roman number 1. Let us prove Roman number 1. Tan inverse x asi a ga manahalabadi left becomes twice a orani. Then this gives x equal to tan a. We have from the sine tan inverse x to na a ga manahalabadi twice a. Sine inverse na from the thanga the sine of twice a. Sine of twice is in terms of tan a, that is assume na phong do a. Class 11 na thengna kiba formula ne. Sine amuk right la abadi sine inverse la a twice a left la hore twice a 2a की value di kaya ga mana hore tan inverse x na sindo kro tan a di kaya ga mana hore x na assume na Roman number 1 do prove tori. Similarly Roman number 2 so I call na tan inverse x to a ga mana ready twice a le cos inverse na formula di cos twice a ni cos twice a in terms of tan da di si ga mana masi class 11 do prove to kraba trigonometric formula amani. Cos na sumasa kavdi cos inverse le implies twice a equal to cos inverse of something. Logic a की value di tan inverse s का मान हौरे tan a di s का मान हौरे अदुना Roman number 2 asisu prove tori. For Roman number 3 sisu twice a ni tan la adi tan twice and we have known that tan twice a is equal to 2 tan a by 1 minus tan square a implies twice a equal to tan inverse of twice tan a by 1 minus tan square a की value di mamang da tan inverse x na sinjang kare tan a di x ka mana kare assume na Roman number 3 asisu prove tori. Properties of inverse trigonometric functions lesson asigi properties sing maji koi matang mayam prove to kare makoi sing ado hojik amuk one by one assume na muk ningsing asi. Last iribat 7 property 1 sin inverse x plus minus sin inverse y is sin inverse of x root over 1 minus y square plus minus y root over 1 minus x square sigma manai. Roman number 2 cos inverse x plus minus cos inverse y d cos inverse of xy minus plus root over 1 minus x square into root over 1 minus y square. Haribo formula amusung number I samu yengsi sin inverse x equal to cos inverse of root over 1 minus x square equal to tan inverse of xy root over 1 minus x square equal to cot inverse of root over 1 minus x square by x. Assume na sin inverse x na cosec inverse study 1 by s ka manai. Sin inverse x na sec inverse study 1 by root over 1 minus x square manai. Assume na sin inverse x na lemo mga da cos inverse na lemo mga da tan inverse na lemo mga da sec inverse na lemo mga da cosec inverse na lemo mga da phongdok pagi formula sigi sample amani matak kisi formula mari ni plus matak lawra plus ama makha lawra ga formula ama matak lawra ga plus formula ama makha lawra ga formula ama hariba formula si syllabus study masi yaugre adu makoi si famous properties of inverse trigonometric functions in exercise 2.2. Prove the following. Roman number 1 3 sin inverse x is equal to sin inverse of thrice x minus 4x cube, where x belongs to closed interval minus half. Anisubada 3 cos inverse x equal to cos inverse of 4x cube minus thrice x belongs to closed interval half 0. Let us prove. Left hand side 3 sin inverse x to theta da putting to thrice theta phange. This gives sin theta the s ka mana re thrice theta haibasi china right left hand side to thrice theta da puto e assume na right hand side adusu puto se right hand side is sin inverse of thrice x minus 4x cube ni x to the kaya ga mana hore sin theta ga mana hore x to sin theta thamo chi x to sin theta thamo sin inverse of manung gi bracket ke expression asi sin of thrice theta ni. Property sin inverse sin x die property to palaga de sin inverse of sin thrice theta di thrice theta phang right and isi manner ne left right ka manner. Therefore left hand side equal to right hand side. Roman number 1 prove tori. For Roman number 2 right hand side to horosi right hand side to sile adudi hojik icon x to cos theta da putting torobadi becomes this. Assume na cd cos bracket asi cos of thrice theta expansion property ama palabadi thrice theta phange thrice theta di kaya ga mana hui theta di cos inverse s ka mana hui masina left hand side ore asumna roman number ko question number 2 asi su prove to lore prove the following three question number 3 10 inverse of 2 by 11 plus 10 inverse of 7 by 24 equal to 10 inverse of half 11 side si formula pan si 11 side si le masi 10 inverse ke addition formula palabadi 10 inverse of 2 by 11 plus 7 by 24 whole divided by 1 minus 2 by 11 into 7 by 24 the 10 inverse ki maning the simplified orabadi we get this amuk simplified orabadi this which is what half or 10 inverse of half machine right hand side to ori hence proof number 4 si su proof ni left hand side ge 11 side si auji horosi 11 side ki 2 10 inverse of half hai basi kaya ga managa ge haraga di 2 10 inverse of x di 10 inverse of twice x by 1 minus x square twice 10 inverse x in terms of 10 inverse to phongdo po yai madu gi formula ro panjaladi we get this si gi formula na si pangai plus 10 inverse of 1 by 70 putharak lani si simplified or the 4 by 3 10 inverse ke addition formula policy 10 inverse of 4 by 3 plus 1 by 7 by 1 minus 4 by 3 into 1 by 7 simplified or already we get this 31 by 17 must be the right hand side hence proof write the following functions in the simplest form makha the period but inverse trigonometric function simplest form the thamo hai question number 5 ni 10 inverse of root over 1 minus x square minus 1 whole divided by x does not equal to 0 1 plus x square urabadi x takona 10 theta putting togone root yaurusu standard substitution di 1 plus x square gi di x ta 10 theta putting tore asum si phange root over 1 plus 10 square theta di sec square theta ni simplified or square root ka square ga root ka mangal di sec theta phange masi amok 1 by cos sec na 1 by cos 10 na sin by cos phongdo over si phangani masi amok sina right hand sina simplest form da thambadu form oidri 1 minus cos theta di half angle da di 2 sin square theta by 2 ga mane sin theta di half angle da phongdo over di twice sin theta by 2 into cos theta by 2 ga mane 2 kakthana ro sin kakthana ro di 10 inverse of 10 of theta by 2 phange 10 inverse of 10 of something this something that is theta by 2 theta di kaya ga mana re theta di aikona hanana 10 inverse s ka mana hore asumna sugumba expression ama sumaina thamba sibu simplest form da thamba kawi masina hayeng matung taba chapter sing derivative am integration da kana rakani question number 6 simplest form ni 10 inverse of 1 by of root over x square minus 1 sisu x square minus 1 urabadi substitution 10 inverse ladi 10 inverse 10 of something tanaba since x the sec theta putting to the c adudi hauji kaya lere sec square theta minus 1 di identity siznaraga 10 square theta phange square do lokhrabadi 1 by 10 theta ni cot theta phange adudi 10 inverse ka cot ka kakthana ba yadamina cot theta is 10 of pi by 2 minus theta ra phungbo badi kakthana ro pi by 2 minus theta phange theta di kaya ga manare theta di sec inverse s ka manare asumba expression ama asumna thamba sibu simplest form da thamba kawi simplest form da thamba du lore number 7 is simplest form ni 10 inverse lady bracket manung si 10 of something tana basin si 1 minus cos x 1 plus cos x urabade half angle da sado o 1 minus cos x di 2 sin square x by 2 ni 1 plus cos x di 2 cos square x by 2 ni root ka 2 ga kathana ra matung da 10 square x by 2 ni 10 square gi square ga root ka kathana ra badi 10 x by 2 pange amuk ani ji punjana ra badi x by 2 simplest form da thambal lore number 8 achi samu yang si cos x minus 10 10 inverse of 10 of something tanable since cos x na yellow cos x na cos x di yellow di 1 sin x di yellow di 10x asuna makha da su yellow di si pange bracket manung si kaya ka manai 10 to pi by 4 minus x ka manai kakthana ro di pi by 4 minus x tare question number 9 10 inverse of something ni 10 inverse of something with that 10 inverse a square minus x square or the x ta a sin theta putting toro asum x ta sin theta le robadi cd a square gi a somtho a kakthana ro 1 minus cosine square gi di cos square ni square kakthana di cos ni sin by cos ti 10 theta ni theta phange theta di kaya ga mane sin inverse of x by a ga mane Sumna number 10 10 inverse of something lerabadi masida aikoina kaidoraga si phangki kane haigaragadi a square a cube na yellow badi si phange makhada a cube na yellow badi si phange a cube na yellow badi si phange x by ac aikoina 10 theta da putting torabadi standard result ama phange bracket manungi expression is 10 top size theta ga expansion class 11 kaktana rabadi thrice theta di kaya ga manai 10 inverse of x by a ga manai simplest form da thambal lori. Find the value of question number 11 10 inverse of this. Let us see 10 inverse this 10 inverse lagi manung 10 of something tana basin say 2 sin inverse half the pi by 3 ga mani pi by 6 ga mani 30 ga 30 and the 60 ni the cos of 60 the 1 by 2 ni 1 by 2 ga 2 ka khana 10 inverse 1 tare pi by 4 lare asumna roman number question number 12 kisu the code of 10 inverse of a plus code inverse a di manung sida identity mas property mas seasonal si pi by 2 ko mane code of pi by 2 di 0 ne asumna number 13 asi suyengsi 13 asi yengsi manung gi asi kaya ga mana ga dage hedu sin inverse of twice x by 1 plus x square di 2 10 inverse s ka mane si standard result ne cos inverse of 1 minus y square by 1 plus y square in terms of 10 di 2 10 inverse y ga mane standard result ne si 2 kamalo to kathana risilare manungi 10 inverse ani si 10 naro you get this 10 inverse ka kathana di x plus y by 1 minus xy hence find out. Now question number 14 if sine of sine inverse 1 by 5 plus cos inverse of x equal to 1 then find the value of x 70. Let us see bracket manung si huji koina kaya phange sine of 1 ke nakana sakari sine inverse 1 expression se lehore sin inverse 1 di pi by 2 ga manare si ani si di cos inverse x di kaya ga manare pi by 2 minus sin inverse of 1 by 5 this is cos inverse of 1 by 5 ga manare comparing to the x ki value 1 by 5 assume na roman number question number 15 here 10 inverse of x minus 1 by x minus 2 plus 10 inverse of x plus 1 by x plus 2 is pi by 4 10 inverse ani si 10 sinarabadi 10 inverse x plus 10 inverse y addition formula palabadi we get this simplify to 10 assume sakari pi by 10 pi by 4 di 1 cross multiply hana simplify to si aduga cross multiply and transfer we get x ki value the plus minus 1 by root 2 phang. Find the value of question number 16 sin inverse of sine of twice pi sin inverse twice pi by CD 120 ni 120 CD magi intervention laite minus 90 amasu pi by 2 gi marakta laitawni sin to pi minus pi by 6 120 habadi 180 degi 60 khaidokro adudi CD sin to pi minus something the sin of 60 lady 60 di minus pi by 2 plus pi by 2 gi marakta laitawni kathana di pi by 3 value tare masina direct formula do panba yade twice pi by 3 habasi 120 ni masi minus 90 amso plus 90 close interval ni marakta level angle natte. Question number 17 madusu 3 pi by 4 asisu open interval minus pi by 4 plus pi by 2 ki marakta level natte aduna usi 10 top asibu pi minus pi by 4 haine ibiyare sidi second quadrilateral angle amagi 10 di minus 10 pi by 4 lere minus to mahakidi mapana mahakidi minus to manung sangkhi biyare asidi minus pi by 4 abadi minus 90 amasu plus 90 open interval marakta level angle ore adu direct formula palabadi minus pi by 4 number 18 let us see sisu amu yang si sin inverse to the sin inverse na 10 the sado for formula di ngasai yaw ki do syllabus study tandabani adu bhoji masi koi formula panjele sin inverse x na 10 inverse to phongdo ki x by root over 1 minus x square ma do panjela si phange 10 inverse na cot mani the reciprocal ni si pale sin hojik pan ki formula do na kan the since the period lere asumna hojik si ki simplify to 3 by 4 phange 10 inverse ke addition formula policy 10 inverse ke addition formula pale aro 10 ga 10 inverse ke kakan si lere si 17 by 6 value puthokpa lore. Question number 19 cos inverse of cos of something is equal to masisi hojik mamang no khokhi do mane sigi di 2 10 have cd 0 to pi close interval ni marak level number na tam ni direct formula pan be yadri si simplest form the apik angle the sadoksi masi 7 pi by 6 asumne ire cos pi plus something the third quadrant level angle ki cos ki minus la ani cos of pi by 4 the return tora ani my cos ki minus to manghan ge higher badi ꯑꯩꯈꯣꯏ ꯃꯃꯥꯡꯗ minus pi minus ꯑꯃ ꯇꯞꯄꯅꯤ pi minus cos inverse of cos of pi by 6 ꯒ ꯃꯥꯟꯅꯩ ꯁꯤꯒ ꯀꯛꯊꯅꯔꯤ pi by 6 ꯂꯩꯔꯦ simplify ꯇꯧꯔꯗꯤ 5 pi by 6 5 pi by 6 ꯗꯤ option B ꯑꯁꯤꯅ ꯆꯨꯝꯃꯦ ꯁꯨꯝꯅ question number 20 ꯒꯤꯁꯨ ꯌꯦꯡꯁꯤ sin inverse of minus half हाइबसिदी minus 30 गा मानै minus 60 द minus 30 हापदी 19 sin 90 दी 1 नी 1 दो option D असि चुमे number 21 tan inverse of root 3 minus cot inverse of minus root 3 asidi tan inverse of root 3 di 60 ga manai pi by 3 adu cot inverse of minus to di pi minus cot inverse root 3 ga manai identity property am seasonabani asumna silare cd kaya ga manai pi by 6 30 ga manare simplified or minus pi by 2 option kana chume b chume